Alrighty, so I'm going to get into 3.9, which you can see by our I can statement. We're going to be determining possible rations of zeros of a function using a specific thing called the rational zeros theorem, but we'll get into that when we get into it. So looking at this function, we have our standard form given to us in as x squared minus, x cubed plus 3x squared minus 10x minus 24. Yes?
Where do I sit?
Anywhere you like. Oh, I didn't realize I didn't scroll in. Zoom in first. Let's zoom in. Just make it a little easier. So, minus 24. The factored form, we have x plus 4, x plus 2, and x minus 3. Because of that, our zeros are given to us with negative 4, negative 2, and 3. X-intercepts are negative 4, 0, negative 2, 0, and 3, 0. All stuff we can find. So I want to ask, how is our standard form related to our factored form? Anybody? Any relation? Well, they're equivalent. They're the same thing. They're just written in two different forms, so they're equivalent. One just shows the factors. I'll give you a hint for a lot of these. They're basically the same thing. So I'm really not going to write much out for these. So how is the factored form related to the zeros? Well, the factored form shows our roots, or the roots of the function. And how do our zeros relate to our x-intercepts? Well, you can see our zeros are just the x-coordinate of our intercepts. Zeros are the x-coordinate, or x value. And we call it the factored form because, well, it's the factors. If you multiply all these together, you get that form out. Because, oh, it's made of the factors. Similar, so if we think of 4, it has the factors of 1, 2, well, 1, 4, and 2. So 1 and 4, 2 and 2. These are the factors that, when multiplied together, make this. So with that little description out of the way, we can get into the rational zeros theorem, which states if the polynomial p of x equals a to the n, which any a to the n, or a's in this, is just the coefficient. So if we scroll up and I can still show it, yep. So in this one, a to the n here would be 1, a to the n minus 1 in this case would be 3, a to the n, or a squared, a 2. A's are just our coefficients to each of our terms. The n just states which term it is. So this is our fourth or third term, so that would be, so this would be a3 x to the 3, which a3 is just 1 in this case. I'm just trying to relate it. So if we have a polynomial has rational, if the polynomial has rational roots, then they must be in the form of the factors of a to the 0 divided by the factors of a to the n. What this is saying, and our conclusion we can draw, is the factors have to be rational roots. So our rational roots are going to be in the form of plus or minus the factors of the last coefficient divided by the factors of the first coefficient. That's a lot to write. I'm going to do some examples. And all we're going to do is find what possible So these are possible. They're not going to be all the roots. In many cases, oops, come back. So these are actually just the a little bit of technical difficulties. It doesn't want me to write anymore. Oh, I love it when it does this. So we're going to refresh the page. Hopefully you guys have that all written down. Well, let me write again. It will. Look at that. So, possible. Make sure we're still capturing. We are. Okay. And we're back. So, when it says possible, we're going to have a lot of different options. So, just as an example, so we have. Really? Okay. So, our last term here is -10. Our first one, we don't have a coefficient, so that means well, we do have a coefficient. It's 1. So, the possible factors for 10. We'll have 1 and 10, 2 and 5, and there aren't any other factors for 10. Factors for 1, just 1. So our possible roots are 1. So on the top we'll write 1, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 5, and plus or minus 10. And on the bottom, our only root for our first term is plus or minus 1. So how we get this is we take every single one of these and we create a fraction with the one below it. So that means we'll have plus or minus 1 over 1, which is 1, plus or minus 2 over 1, which is 2. So I'm just going to skip. So since we all know what these numbers are divided by 1 is, so our possible rational roots are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So, as you might be able to guess, this is only a degree of 3. So that means there are 3 roots. That means not all of these are going to be a working root. We'll get into finding out which ones are the correct ones in a bit. But first, I want you guys to take a second. Try this one on your own. Try to find all the possible roots for this first. For 2x cubed plus 3x squared plus 2x plus 3. And just a reminder, if there is another term in the denominator, you have to then make the same fractions again with it as well. So you need to do one for everything. Alrighty, so let's start off with our last term. What are the factors of 3?
1 and 3.
1 and 3. Perfect. What are the factors of 2?
1 and 2.
1 and 2. So when we set this up, we'll have plus or minus 1 on top, plus or minus 3, and we'll have plus or minus 1 and plus or minus 2. Oops. So to get our possible roots, we didn't do our combination. So 1 over 1 is 1, so we'll have plus or minus 1. 3 over 1, so we'll have 3, plus or minus. Then we'll have the 1/2, plus or minus 1/2, and plus or minus 3/2 is all of our possible rational roots. So the reason why we're even doing this, and the reason why we learned long division, is that's actually how we're going to find it. So first, I actually want you guys to get your Chromebooks out, or you can use your phones. Look up this in your Google, You'll find a nice handy little website that'll look like this. Yes. It does capture properly. Yes, it does. And then we're going to fill out this table. I'm going to give you guys a couple minutes, but we're going to do the first one together once you guys get situated. So you want to type in our equation or our function. Did not mean to cross over that. Into the dividend portion, and the divide, and then the divide by. I want to start with the x plus 2. So once you do this, all you have to do is hit submit. It'll do some magic maths. And we'll find out that our remainder, as you can see, is 0. So we can go back, we'll find our remainder is 0. When we write things as a 0, just like before we do, so x plus 2, we set them equal to 0 and then solve for x. So our divisor here is going to be -2, or our divisor as a 0 is going to be -2. Is the divisor a factor? Well, since we do not have a remainder, that means yes. And because it is a factor, and because we have a remainder of 0, that makes it a 0. So that when we plug our 0 in, or our value in, so -2, when we plug it in, we'll get 0 back out. So, I want you all to take a minute, try to fill out the rest of the graph. All you have to do is update the divide by thing, and it'll resubmit. Click resubmit, and it'll give you the new answer you're looking for. So if I do, look at my chart. So the next one is 6. It is plus 6. So just like that. I want to give you guys a couple minutes to work on that, and then I will come back. Okay, so once you go into are you at the website? First off. So you're right here? Okay. Well, so it should look like this, correct? Alrighty. So you type our function into the first box, and then you type your divisor, one of the divisors, into the second box. I'd recommend starting with the second one since we did the first one together. Or I did the first one for us. So I guess I'll do this one as well. So when we do that, when we look at it, we're looking at this last box here, because that tells us what our remainder is. And that, so we know that this is now 0. To find our divisor as a 0, we set it equal to 0 and solve for x. So because our remainder is 0, that means that yes, it is a factor. And if we plug -6 into our function, because it is a 0, we should expect a 0 out. And that's what we get. these are the answers you should have gotten. If you don't believe me that when we have a remainder, when we input it in, we get the same exact value out, well, here we are. Back in Desmos, I have the same function typed in. So when we put in -8, we get 1920 out. If we put in +3, we get -225. And every other value that we have here is a 0 for this function. So next thing we're going to start putting all this together. So we're going to first find what are the roots for this function. Just like before, we'll take our possible or our factors. So possible factors for 1 is just 1. Factors of 4 are 1, 2, and 4. So our possible, remember so 1, 2, and 4. So all of our possible roots are plus or minus 1, plus or minus 1/2, or plus or minus 1/4. So how do we, in using this, we can figure out exactly that. So let me go to 4x to the 4x squared, so 4 cubed minus, nope, 4x cubed minus 3x minus 1. One of our possible factors. So we need to put this into our divisor form. So we'll have x plus or minus 1, x plus or minus 1/2, and x plus or minus 1/4. So let's just try x plus 1. See what that gives us. Gives us a remainder of -2, so that is not a valid function. So let's try -1. That gives us a 0 as a remainder. So one of our roots is that x equals, well, it's going to be at x minus 1, so at x equals 1. Then we'll try 1/2. And that's literally what this is going to be. It's going to be trial and error. So at x minus 1/2 doesn't work. We do plus 1/2. It does. So we'll have at x plus 1/2, or x equals -1/2 as a 0. And we have one more, so we'll try the rest. Should be 1/4. So 0.25. We have a remainder. And at minus 0.25. We also have a remainder. So none of them is the 1/4. What that means is one of these has a multiplicity. And it is actually, if we use Desmos, I can show you. Hello? That didn't work out properly. 4x cubed minus 4x minus. Oh, no, I'm just so far zoomed out. So using Desmos, we can find that because it comes in, it just touches and bends away. Our 1/2 has a multiplicity of 2. So we'd write that as multiplicity of 2. The way we can find that is by doing this all over again. So if we go back into this and we put it in as minus 0.5, sorry, plus 0.5. How we can check that is we take our answer and we put it in. So our result is going to be 4x squared minus 2x minus 2. So that's what we would put in here. So 4x squared minus 2x minus 2. And when we do that, we'll get another remainder of 0. So that means it is a multiplicity of 2. It is a 0 twice. So last but not least, we're going to determine if the linear binomial factors that were given here are zeros for this function, or are factors for this function, using long division, or polynomial division. You could use box method or long division, whichever method works for you. For these, I'm going to use long division, just because I think it works nicer for me. So we'll have x cubed minus 8x squared minus 21x plus 108. So we'll get x squared. When we do that, we'll get x cubed minus 2x squared. Flip the signs. Our first ones cancel out. And we'll get minus 6x squared minus 21x plus 108. So this has to be 6x. So we'll have minus 6x plus 12. And we flip the signs. No, that's right. So this, when we flip the signs, that would be 33x plus 108. That should be minus 33x, so minus 33. Oh, minus 33x plus 66. I don't remember that off the top of my head. All we know is that it's not 0. So we'll have a remainder. Oh wait, that's just adding 36. 172. 174. So, this first one, no, is not a factor. Then we'll try the next one. So x cubed minus 8x squared minus 21x plus 108. So again, we'll start with x squared. So we'll have x cubed minus x squared. Flip our signs. Plus minus x squared. We'll have minus 9x squared minus 21x plus 108. So minus 9x. We'll have a negative 9x minus 9x. Flip our signs. First ones cancel. That should be 12x. Negative 12x plus 108. Might be able to guess already that no, this will not cancel, or will not. Let me flip our signs. It is also not a factor, because we'll have a remainder of 120. Last but not least, I'm running out of space, so I'm going to hopefully drag this over some. Alright, that's pretty funny. So x squared minus 6x minus 13. Oop. Oop, come on, come back. Right there, proper function. So x cubed minus 8x minus 21x plus 108. And we'll have x plus 4. Starting off the same, we have x squared. X squared plus 4x squared. Sorry, x cubed. Keep making that mistake. When we flip our signs, those cancel. We'll have negative 12x minus 21 plus 108. So we'll have negative 12x here. Ooh. That should be x squared. That should be positive x. Should be x. So this would be minus 12x squared minus 48x. When we flip our signs, we'll get 27x plus 108. So that means our last one is 27. So that's plus 27. 27x. 27 times 4 is, in fact, 108. So when we flip our signs, they cancel out perfectly. We get 0 left over. So yes, x plus 4 is indeed one of our roots. Yes.